Hello everybody, welcome back. This is Tesfaye. Today we are going to start a new section about data types in Java. There are principally two types of data types in Java programming. These are called primitive data types and non-primitive data types. So the difference between the two is that primitive data types are predefined by Java, and they are already there, except we call them. They are predefined, while the non-primitive data types, we define ourselves, we create them. That's the main difference. That we could have said primary and secondary, but it's not like primary and secondary. It's a primitive. Ones are already there, pre-defined for us. Primitive data types has always values. They should always have values. If we define them, we should give them a value. While the non-primitive data types, we don't have to give value. They just can occupy space or memory, and then can be used any other time. That's another difference that we have. Maybe it will be clear when we see them in practice as well. The main difference actually is that primitive data types are defined by Java in the Java programs, in the Java language library, for example, while non-primitive data types, the programmer should define them. And with this, we're gonna see their classification. So we have in primitive data types, we have numeric data type and the character data types. In numeric data type, we have bytes, ints, long, float, and the double. We will see them one by one. In the character data types, we have the char or char we have seen in our previous program. We already have seen these data types, but we just see how they are defined and being called in the programs. In non-primitive data types, we have strings themselves, the string data type, the arrays. In the array category, we have the int array and string arrays. We will see this in this section. So I hope this will help you to understand what kind of data we use in Java. Let's do the primitive data type first. So in this program, in this tutorial, I'm going to present you to the primitive data type we have in numeric. So I'm gonna say primitive type numeric. Okay, for our consumption, and I include the main method here. So we already saw them one by one. So one is the smallest of all is called byte. Okay, as you can see, it is colored, means it is already from Java itself. So let's say byte b equals byte, as we have seen. These integers are numeric, so we can give any integers. They occupy eight spaces, 8, 0, and 1s. Okay, like this. So about memory related to this, we learn about memory management in Java, especially when we define. We will see some of them here. Okay, so these ones, byte stores a number between -128 to 127. This is what they can store. Any number between these two can be defined as byte. But if you put +1 to, like, if you put this 1 8, it can't be byte. It will be it gives you error if you define like that. It has to be between these two numbers. More or less will give you an error if you define as it is. As you can see, we can define any number between these two as, for example, as integers. And we have been defining as integer 12 as integer and so on. So no problem at all. But the problem is when we define as integer for a small number, we are giving large space for a small number when we can actually define it as byte and then give a small memory for that. So this is one primitive data type. Okay, the other one is short. Okay, short is also a small number but bigger than byte. It can store data between 32,768. This is a large number, so in thousands, to 32,000, just one less, 767. So if it is 32,768 and defined as short, that gives us an error as well. So this is a large number again. If we define any number between this negative and the positive value as a short, we can still store, giving it a reasonable space. And if we define that as int, I'm going to show you int actually, which we commonly know it. Int I can define, let's say define as I can give it a 12 as I said, but as you can see, this is 12 can be defined as byte or short. But usually this is a very common, int is a very common numeric value we use for age, for any type of numeric values when it doesn't have decimal places. Of course, for decimal places, int doesn't work because we have to define it as a double or float. We'll see those next. So for int, this int has a large place. I can write this to you from minus 214,748,3648 to 214. This is in thousands, okay? 748 and 664. It has 26471 number less. This is a huge number, isn't it? So it is in millions. This is in millions, as you can see. So imagine for 12, while we could just define as a byte, we give that long space which can store this in millions, and then we waste our memory. This is what is very important in programming and in memory management in programming. So this is another primitive type. The other primitive type is what is called long. It's very self-descriptive. This is number in huge arrays. So we can define, let's say, to show it just a big number. So it has to have always L at the end. Okay, that's not 1, that's L. And this stores minus 2 the power of 63. That means 2 plus 62 and 63 zeros. I don't know how to read it. 2 plus the power of 63. So this actually stores 64 byte. 1 byte stores, 64 byte. 1 byte stores it can store 1 character. So, or it can store multiple of this many times. So this is a huge number. So if we don't have to define that, because if we define, we use the memory, overuse the memory. The memory gonna be wasted. We don't store another. If this occupies a space, it doesn't store another one until we redefine it. So this is integer primitives, okay? But there are float primitives, which are used to float data types, okay? These are used to store numbers with decimal place. The first one, very common one, is double. We call double D. I'm just giving it D or whatever you say. So this is a decimal place. There's no exact difference between these two except the size again. This is a very huge size, occupies very huge size. I'm going to write to you this. It's 1.7, as you can E minus 308 to 1.7 E plus 308. So this is huge number. One is negative, one is positive, as you can see. And the next one is float. We have seen this float as well. Okay, float f equals, let's say, we can actually give the same number, but it's only the difference is the size and the format of the number. This is huge number, which is 3.4 E, okay, minus 0.38 to, sorry, I should have made it comment to this actually means we can redefine this as 3.4 times 10 the power of minus 38 to the other side of it, the positive part, E plus, sorry, plus 0.38. Okay, so here is another very large number. So this is the largest number we can store. Okay, so as you can see, we have 6 type of numeric primitive data type in Java. We can print all of them. Let me print one by one. So system dot out dot println. What am I going to print here? This is a byte primitive data type space plus B. Yeah, this will print the first for me. I'm gonna copy that, print, duplicate that for ease and the quickness. Paste that, paste 2, 4, 5, 6. So this one is short, and I put short here. This is what I defined up there. So this is integer, this is long, and this is for double, and this is for float. So just make the reading correct. Okay, and this one is double, this one is long, isn't it? Long, yeah, and this one is int. I think we're finished, so we don't see any error. If we print that, we have all the output with description. So this is short data type, this is byte. Short data type, this is integer. And as you can see, the addition of LF here, the L, the F, the D doesn't affect the output or the program itself. That's because it is how Java understands that it is double, float, or long. So we can't add to maybe to others like this one. Let me add I to it. As you can see, it gives me an error. Those doesn't need any kind of formatting there, but these ones need those. Okay. If we let me show you, if we duplicate the error we were saying, if this is 128, as you can see, this is out of range. This is out of range. Otherwise, we have to define it as integer. So change type to string. So we can't go beyond that one. But if we change to 27, it will accept, as you can see. So this is very important when programming for memory management, plus for also knowing what to define how. And I hope this is helpful. Thank you for following me, and we'll see you in the next program. Bye bye.